right, so this is Explain 2. It is on page 203. And so if you want to follow along, get your textbook out and you can kind of take notes. So here what we're looking at is discrete graphs, continuous graphs. We're also going to look at domain and range. So this is everything that you have looked at in the past. So modeling with linear functions. So a discrete function is a function whose graph has unconnected points. So I know that if I have a graph here, a discrete graph is going to have points that the value is just dots. So it's going to be whole numbers. So a whole number input and a whole number output. But a continuous graph is a function whose graph is an unbroken line or curve. So this one here is discrete. So this example here is discrete. And then my next example here, so I'm just going to make it tiny. So here is another graph. And so if I have an unbroken line or curve, so this here would be a continuous graph. Because I know it has arrowheads on it, it's going to continue on and on and on. So this one is a continuous. So this is a continuous graph. All right, so for example, a function represents the cell of individual apples. Is it discrete? Because you would not want to buy half an apple. That would not be good. If someone else fit into it. So you would want that to be a whole apple. So a function represents the cell of apples by the pound. So if I want to buy 3.5 pounds of apples, I could do that. If I wanted to buy 4 pounds of apples, I can still do that. But the result can be a fractional part. Right? So if I get 6 apples and maybe they weigh 2.5 pounds or 2.25 pounds, so that would be a continuous graph. So our example here, so same thing, Sal, he owns a video store and he pays the film studios $2 for each DVD video. So he does not want to purchase a half of a DVD. So he buys. The amount Sal pays is given in my function. So my function here is f of x is equal to 2x. And so this is an input-output. So if he doesn't buy any videos, he doesn't have to pay anything. So therefore, that's why it starts at 0, 0. If he buys one video, so we just substitute that in there for x, and then say 2 times 1, so that's 2. So if he buys one video, he pays $2. And you can see here, my x value is the number of videos, and my y value is the cost that Sal is going to pay. So 2 then, my input, we buy 2 videos. My output is 4. He's going to pay $4. So I'm just going to graph that 2, 4. And then 3 videos, 3 times 2 is 6. So my output is 6, so 3, 2. So this is a discrete graph. We only use points to plot it because you cannot, or you don't want to, purchase a half of a DVD. So this is a discrete graph, and so there's a pattern here. So you can see that it's changing by 1, it's changing by 1, it's changing by 1, changing, so this is changing by 1. But on this side over here, I know 2 minus 0, so this is 2, so it changed by 2. 4 minus 2, it changed by 2. 6 minus 4, it changed by 2. And then 8 minus 6, it changed by 2. And remember, we take the second value and we subtract the first value to get that change. And so that's why we say 8 minus 6, 6 minus 4. So to get that change of 2. So what I know here is this is a discrete function. Since the number of DVDs must be a whole number, the domain then is written like this. So my domain is 0, 1, 2, 3, da, 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 da. okay? And then my range is by twos. So 0, 2, 4, 6, 8, dot, dot, dot. Okay, so that is what my domain and my range is. Okay, so let's look at one now where it's a continuous graph. Elsa rents a booth in her grandfather's mall to open up an ice cream stand. She pays $1 to her grandfather for each hour of operation. The amount Elsa pays each hour is given by the function f of x is equal to x, where x is the amount of hours her booth is open. So if she's not open, she doesn't have to pay anything. So that's why it starts off at 0, 0. So if she's open 1 hour, she has to pay $1. If she's open 2 hours, she has to pay $2. And right now I'm plotting the points, is what I'm doing. I'm just plotting the points. And then if she's open 3 hours, she has to pay $3. Oops, that's not 3. It's in here. And then if she's open 4, so I'm just substituting that in for x each time, she has to pay $4. Now she can be open, let's say an hour and a half. So that's why this here is a continuous graph, because she doesn't have to be open for a full hour. She can be open a quarter of an hour. She can be open a half an hour. So depending on what she's open, what she's going to have to, the number of hours she's open, she's going to have to pay rent on her ice cream booth. So the domain and range this time, so this is a continuous graph. So this is a continuous function, input, output. And so the domain now is all real numbers. So I know my x is my domain. So I know my domain is all real numbers greater than or equal to 0. So that's what my domain is. And then my range here is all real numbers. So greater than, so I'm going to say y because that's what my range is, greater than or equal to 0 as well. So that is what my domain and what my range is, writing that as an inequality, because it can be any real number in there. It doesn't have to be 1, 2, 3, 4, 5. So let's look at the reflect. Why are the points on the graph in explain to connected? Because the points on the graph are connected because fractional parts of hours are possible, so the function is continuous. And so that's what I kind of already said. This is because she can be open for 15 minutes, or a half an hour. So how is the graph of the function in explain 2a related to the graph of an arithmetic sequence? And you know what, we did not do that section, so we are not going to do discussion 9. So there is the answer. You can pause it and take it down, write it down if you would like. Okay, so let's look at our last one here. So I'm gonna pause this video and create a new video for the next one.